Okay, these are the notes for elimination, linear combination. Sometimes it's called elimination, sometimes it's called linear combination because you're combining lines. So you can see those words in linear combination. Sometimes it's called the addition method because you're adding or subtracting equations together. Remember, subtracting is just adding a negative, so you can think of it all as the same thing. One of the things we're going to have to get used to is in this section is looking for things that when we add them, they cancel each other out. Those are called additive inverses. So for instance, if I have a 5x and I want to get rid of it, or I need a minus 5x to get it to add up to 0, because 5x minus 5x is 0, just as 3x minus 3x would be 0. So basically you're just looking to have this same term but opposite signs, so they'll cancel out and go away. What you're trying to do is end up with one variable left so that you can solve the equation. So we're going to have some steps today that we're going to talk about. It's going to be to put equations in standard form first. If you look at all these three examples down here on the bottom, they're all in standard form. The x and the y are on one side. There are no fractions. We don't like fractions, so we get rid of those first. If the book gives you any fractions, you'll just need to get rid of them. We'll multiply through by something, and let's see. Then we're gonna look for variables that'll cancel. We're going to find the additive inverse if we need to and multiply. We're going to cancel and eliminate one variable and solve for the other variable. And then we're going to substitute a value of a variable into an equation to determine the other variable. Okay, so we'll start the first problem and you'll see what we mean. Okay, our first problem on our note sheet says example 1 is x plus y equals 6. And 2x minus y is 9. This is the kind of problem you love to get because if you're looking for one of the variables that it's the same value but with an opposite sign. And if you look, this one's set up perfectly for that. You have a plus y and a minus y. It didn't have to just be a y. It could have had a number in front of it, but if it had a number in front of it, we needed to see it both places with opposite signs. So what I'm going to do is just going to add these equations together. And when I do, the y is going to cancel out, or it's going to add up to 0. X plus 2x is 3x. Y plus minus y is 0. It cancels out. I could put plus 0, but usually we don't write that, do we? So I'll take that out. Okay, and that would be equal to 15. This method, most people like it a lot, okay, because it's usually fast to do. If I want to solve for x, all I have to do now is, I can divide by 3, and I'll have x by itself, and I'll know what x is. 3's cancel out on the left-hand side. X is 5. Oh, there's my part of my answer. Now, remember, my answer is a point. We need the x, and we need the y. And the x is 5. And so let's go find the y. How will I find the y? Choose one of the equations. Plug in. Choose one of the equations. I got ahead of myself there. And plug in x to find y. Okay, so you're just trying to get one of them to cancel out, and if it's not set up where it'll do it automatically, we'll make it happen, in other words. Okay, so if I want to find y, I'm going to choose x plus y is 6. But I know what x is. It is 5. So 5 plus y is 6. If we subtract 5 from both sides, y equal 1. Oh, so that's the other part of my answer. I'm going to take that and write it up here. My coordinate point, y is 1, and I'm done. Equal 2. X plus 3y is 2, is one equation. And x minus 2y is negative 3. They're going to start you out with some really easy ones first, so that it's not so hard to get onto the harder ones, because you kind of get used to things a little at a time. Now, if I'm looking here, I notice that I have an x and an x in both. But if I added them together right now, I would get 2x, not 0. So what I'm going to do is I'm going to come through and I'm going to multiply the second equation by -1 before I add. So that means that now, here's what I have. I have the first equation. It's still the same. Try to organize your work nicely. You're going to get confused in these problems as they get harder. If you're just trying to write and scribble stuff out on one line and keep from writing it, organize your work neatly. That's most of really what it takes to see the patterns that are in front of your face in math, okay? Now that second line, I'm going to multiply it by -1, so -1 times x is -x. -1 times -2y is +2y, and -1 times -3 is a +3. Basically, all you got to do is change the signs on each term, and you can accomplish it by multiplying by -1, dividing by -1, or just going and changing all the signs and saying, hey, that's what I did, you know. Okay, so now x minus x is 0, 3y and 2y make 5y, and I get 2 plus 3 is 5. So if I want to now find my variable, I've only got one variable left, and I can solve for it. I can divide both sides by 5, and I get y is 1. Okay, so I've got half my answer. My answer is a point. It has an x, it has a y. Y is 1. I need to find x. I'll plug in y. I'll just pick an equation. Either one's fine, whichever one I like the best. I am going to go with the second one. Okay, so I'm choosing the second equation here. X minus 2y is -3. I'll just take it the way it was originally written. I don't know what x is, but I know that y is 1. So x minus 2 is -3. I'll add 2 to each side, and I'll be able to figure out x. X is -3 plus 2, which is -1. I now have all of my answer, and I go plug it in up here. Okay, so sometimes we subtract if we have the right numbers, but not the right, not the right signs or something. We could go through and multiply by -1, so that we're just adding the inverse. Most of the time we think of it as adding, though. Okay, so that third example, 2x plus 4y is 16, and 3x plus 5y is 19. All right, if you look at these numbers, I do not have, if I look at the x's, one's got a 2, one's got a 3. If I add those or, try subtracting or something, it's not going to work out. They're not going to cancel out because the number's not the same. Same thing with the y's. If I add those right now, they're not going to cancel out either because that's going to add up to 9y. So I need to get something to have the same number out front. So here's what you do in this case. You go, okay, I'm going to choose to get rid of the x's. Okay, so if I want to get rid of the x's, I need to get something out in front of both of them that's the same. So here's what I can do. I can say, you know what, the smallest number that 2 and 3 both divide into is 6. Okay, so since 2 and 3 divide into 6, let me get a 6 out front. How will I get a 6 out front of the x's? Well, 2 times 3 would give me 6. Now, when I put this 3 out here, I'm going to have to multiply every single term in the equation by 3, not just the first one. And so I'll do that in a minute. And now, before I forget what I'm doing here, in the second equation, in front of the x, I have a 3, and I want to get a 6 there too. Well, what would I multiply 3 by to get 6? I need to multiply it by 2. So I'm going to multiply every single term in that second equation by 2. When I do that, I'm going to get 2 new equations. The first equation, if I multiply through by 3, would be 6x plus 12y equal 3 times 16 is 48. Do not forget to do every single term, or you're going to have wasted your time working, okay? In the second equation, 2 times 3x is 6x. 2 times 5y is a positive 10y, and 2 times 19 is 38. Okay, now I should have made one slight minor adjustment, and if I don't remember it at the beginning, I can do it now. What I could have done, I didn't want 6x and 6x, that's going to add up to 12. So I want one side to be negative, or one of the terms to be negative. I'm going to pick the bottom one, because if you look, aren't the bottom numbers in the rest of the equation smaller? That way when I subtract, at least I won't, in this problem, I won't have to worry about getting negatives. So I could have multiplied by a negative 2. So I'm going to also multiply by a negative. I can't fit it in there. I put it above the 2. Let me circle it in yellow to show you where I wrote it. So I'm going to go fix that now. Or I'm just going to do it in the second step. You can look at it either way. So if I multiply, I already did the 2 part. I just need to multiply by a negative number, or negative. Well, negative times a positive is a negative on this one. 10 is positive. If I multiply it by a negative or a negative 1, if that bothers you to say negative, that's going to be a minus 10y. And negative 1 times 38 would give me negative 38. Now, when I go to add them together, 6x plus negative 6x would give me the 0 that I want. If it doesn't really add up to 0, you're not doing it right. So you've got to make sure you've got all the signs changed before you go do that. All right, so continuing on, 12y plus a negative 10y would be, or 12y minus 10y is another way to say it, would be 2y. And 48 minus 38 would be 10. Oh, that's an easy equation to solve now, right? If I want to get y by itself, I'll just divide both sides by 2, and I'll find out my y value is 5. Yay, my y value is 5. I have an x part of my answer and a y part of my answer. If I don't have both parts, the answer is not correct because you're telling somebody the wrong point. That's the solution. Remember, when we first started all this, we were graphing to find the solutions. We were seeing the point where they crossed. With substitution and with this new method we're doing here, we're still finding the point where they crossed. We're just going to do it algebraically. Okay, so I know y is 5. What do I do now? I need to find x. So I already have the y value, plug in y. I don't always have to find, it doesn't matter which one I find first, the x or the y. It's just whatever I find, I plug it in to find the other missing one. Okay, so I'm going to choose 2x plus 4y is 16. Okay, so I don't know what x is. I know that y is 5. So that's 2x plus 20 is 16. If I subtract 20 from each side, can't hardly fit it in, but I'm going to try, I get 2x is 16 minus 20, and 16 minus 20 is negative 4. So if I want to find x, I'll have to divide both sides by 2, and x is negative 2, and ta-da, we did it. So sometimes you have to multiply by a negative number, just a negative 1, just to change signs to get things to cancel out if they don't automatically cancel out. And then sometimes you're going to have to multiply both equations by a number and maybe one of them by a negative if you need to get them to cancel out. The ultimate thing is you've got to have opposites. You've got to have, for instance, here we had a 6x and a minus 6x. That way we added them together, they canceled out and added to 0.